Now that we've cloned our Sonnets Plus flat file solution into a Sonnets Plus DB solution, let's talk about the overall architecture of reading and writing to the database. Microsoft on the Microsoft Developer Network, or MSDN, has a great article just recently published called Local Database Overview for Windows Phone. And there's lots of nuanced detail in there, which you'll probably want to review after you complete this section. But what we want to talk about right now is just the architectural considerations on how we're going to connect up this database to our lists, which are done with Silverlight data binding. So the way that's connected, you can see over here in the blue square, inside isolated storage, you can now have SDF files, which are Sqlce database files. The orange arrow in the middle there says that you use link to SQL to talk to that database. And the way in which you use link to SQL is the system.data.link namespace has a data context object which implements the same kind of data context functionality required for the Silverlight data binding. So what we're going to do is we're going to add a reference to that system.data.link, and then we're going to go ahead and start converting the bits and pieces of our Sonnets Plus DB application to use the database. So now let's open Visual Studio and get started. The first order of business is to open the Solution Explorer, open up the references, and add a reference to system.data.link because that's what we need in order to be able to talk to the database. Come down there. There we are, system.data.link. Now, the next thing we're going to do is go to our Sonnets class. Now, this is our Sonnets class from the flat file version. You can see we simply have a collection of properties that we used to read and write data from the XML. When we convert that to the database version, it looks very similar except that there are a number of attributes associated with each item. First of all, we added a couple of additional using statements in order to be able to bring in the assemblies that support these attributes. And then this is the equivalent of the DDL to define the structure of the database. We start out by saying Sonnets is a table in the database, and we define each one of our properties as a column. Now, because this is a database and we want to be able to do queries against it, we also want to have a primary key. And so this collection of stuff right here is all the magic link stuff that says that we want this column Sonnet ID to be a primary key. We want the database to generate it for us. We want the database type to be integer, not null, and we want it to be an identity column, which means it's got to be a unique value. We set can be null equal to false because there's no point in having a primary key that's null because we can't search on it. And then we say autosync equals autosync.onInsert, which means that when we insert something, that's when the initial value of the primary key is generated. But beyond that, our properties look the same, other than they say that they are now columns in the database. So this is, in terms of a database setup, all that we need to do. We don't need to open up SQL Server Explorer and go through wizards and dialog boxes and grids in order to be able to create the data, especially because this data is being created in the Sqlce database on the phone inside your app's private isolated storage. So we'll save that. And now we need to be able to connect up that table definition to the database using a database context class. So we'll come back to the Solution Explorer and add a new class, and we'll call it Sonnets DB Data Context. And when we fill that in, here's what we got. We got some using statements, which are similar to what we had before. We have system.data.link and system.data.link.mapping, and we have a class which implements the system.data.link data context. It only has two things in it. One of them is a declaration of a property which represents the table, which is a type table of T, and that specifies items so that we can use the existing data binding because we're going to be using items. And the constructor, which is, because this is a system.data.link data context, also has to have a connection string, and we have to pass the connection string to the base class during construction. Now, the item view model is going to remain the same, but we need to make a few more changes to the app.xaml.cs in order to be able to support the initial process of using the database. So here's where we're going to actually start accessing the database. Let's take a look what we got. If you remember back in the previous version, we had a DB name property. Well, that's gone now. We have replaced that with a DB connection string property. And since this is actually SQL, it needs to say data source equals. And then you see here isostore:/. So this is a specific string format that tells the database that the connection is in a database and in the isolated storage. And in our case, we called it sonnets2.sdf. Whatever databases you create have to have a file extension of SDF. Then, in order to be able to connect to this data context from other parts of the application, we define a private instance variable of type sonnetsDBDataContext, which we just looked at, and a property getter and setter that allows us to know that we need to actually do the construction the first time we access this and pass in the database connection string. If we look at the rest of app.samplec, most of it is the same as we've seen before, except at the beginning of the app constructor, we initialize a variable of type sonnetsDBDataContext and call our property in order to actually instantiate the database. And we'll use it down here a little bit further on. And just as we did before, we need to determine whether the database has been prepopulated by the Shakespeare sonnets.xml file. Here, unlike in Sonnets plus flat file, we use the database data context in order to be able to query whether the database exists rather than the isolated storage manager and trying to see whether the file exists. So we first ask the system.link.data context whether the database exists. If it doesn't exist, then we create it with this db.createDatabase that does introspection over the table class and actually creates the table in the database with all the appropriate types. Then, just as we did before, and this method hasn't changed, our load database from XML, which reads the Shakespeare sonnets.xml and creates an observable collection of item view model. And then, instead of taking that and writing it out as a serialized XML file, we're going to iterate over the collection of item view model instances and ask the database to insert the items. But it inserts them on submit. So what happens here is we say database.items.insert on submit, and we create a new instance of that sonnets class that has the data that we want, the one that was annotated by the attributes that describe the columns and their data types. You notice because we are using the default values, we don't set the sonnet ID, that's the primary key, which is auto-generated, and we don't need to set the isFavorite value because it defaults to false. So we say db.items.insert on submit, we create a new instance of sonnets, fill it in, and when we're all done with that, then we say db.submitChanges. And that actually takes all of those objects that were in the observable collection and writes them out to the database. As always, depending upon the size of the data that you're dealing with and the amount of memory in the device that you're dealing with, it works great for 154 sonnets. If you had 10,000 U.S. Census data items, you probably would want to call db_submit_changes earlier than at the end of calling insert on submit 10,000 times. So now we have the database set up. We've got our sonnets class with the proper attributes. We've got our db_data_context class all set up, and we've seen the first instance of accessing and writing data to the database.